Okay, now that we've found some outliers, let's talk about what to do with those results. By the end of this lesson, you'll understand what to do with the outliers we had previously identified, as well as some things to consider when evaluating results. You'll also be able to identify possible sources of false positives that we may have to look for in this step of the process. Now that we have some outlier events to start using to find initial malicious activity, we need to start evaluating each of those hits to determine if they're actually malicious or not. Unfortunately, there is no concrete method that I can tell you that works 100% of the time. It is very subjective. A lot of times we are looking for things that are either out of the ordinary or that we can tie back to known adversary usage patterns. We can get those patterns from cyber threat intelligence reports, attack, open source reporting, or other threat reports that we might find in the open domain. You can also leverage your own threat emulators if you have those working with you to provide insight on the events you are seeing. When we are evaluating our hits, if we have already gone through this cycle before, then we should consider whether or not we can tie those events we are now looking at to others that we have already confirmed to be malicious. If we can tie them causally together or infer some relationship, that might give you some certainty they are probably malicious, even if they don't look malicious initially. If we don't have any other events that is tied to, we'd ask ourselves some questions that might give us a better idea if this is malicious or not. A big one that we will often ask ourselves is how often does this activity occur across the environment? And not just across the environment, but across time. If this kind of event is observed across, let's say, all hosts in the network, it is more likely to be something like an update or a job pushed out by administrators than an adversary, although not necessarily. If, however, events that look like this only occur once or twice in the environment or on a small number of hosts, that might increase the unusualness of the event, thereby perhaps indicating it is malicious. Similarly, we should consider whether this event looks similar to other events that look like it. For example, if we see a scheduled task event, we should look across all the scheduled task events that may be occurring in the environment to assess whether it looks like those or not. Perhaps scheduled tasks may be normal in the environment. However, this specific usage is very abnormal and may indicate to us that it is malicious usage. Before assuming it is malicious, we should consider perhaps it is just a rare usage by someone like an administrator or an employee, and it may be worthwhile deconflicting such results with the person who is responsible for executing them. This step is often where network defenders are defined as being successful or not. Most organizations are not at a loss for finding events or alerts. The challenge is being able to correctly interpret those results to find the actual malicious events within it. A lot of the work we have done up to this point is to help make this specific step and decision point more likely to be successful for network defenders. I have worked with teams at events on numerous occasions where they struggled with this specific step and therefore could not achieve success. After all, if you can't find any malicious activity, then no matter how many events we look at, we will never find the adversary. Cyber threat intelligence provides us a way to determine if the events we are looking at might be associated with known malicious activity or not. We have talked a lot about this in previous modules. I won't go into detail about cyber threat intelligence itself. If you want to learn more about it, feel free to visit the cyber threat intelligence courses offered alongside this one. I want to focus primarily on how we use this cyber threat intelligence to aid us in ascertaining whether or not something is malicious. Because cyber threat intelligence will often contain known malicious strings or content of fields that we can associate with malicious behavior, if the behavior that we are seeing appears similar or the same, we have a higher confidence that the events we are evaluating are in fact malicious. Now, we need to be careful assuming that just because what we see matches known malicious behavior, that it is definitely malicious. As we've discussed before, adversaries will often use techniques in such a way as to blend into the environment. So we should consider whether or not this event is unusual for the environment or not. It could be that in this environment, this particular way of performing a specific behavior is common. For example, using encoded PowerShell to execute scripts on machines throughout the environment. There is a legitimate reason for doing so, but it's also a very common adversary technique. If we want to determine if it is malicious or not, then we would have to go a step further and either decode those strings, in this example, or speak to the users responsible for that activity. The example here on this slide is a couple of different ways that open source threat intelligence has reported scheduled tasks being used. As you can see, how it is used can vary significantly between different groups and tools. But if we saw something like a new scheduled task with the name of MySC being run as system, we might have a higher confidence that the usage is malicious than if we saw some other generic combination of scheduled task execution. False positives will often make up the majority of the events we see unless we have very good analytics. There are many potential sources of false positives, but a big one we see in networks is from network administrators or other network administrative tasks. While normal users will often not behave in a way that might appear to be a malicious actor, administrators are often using the same tools and some of the same techniques adversaries use when they're within the network. For example, it is not unusual for network administrators to need to move laterally through the network, perhaps for troubleshooting someone's box, or jumping to an administrative system from their own. They will also do things like manipulate accounts, automate tasks using scripting, compress data before and moving it to other locations, etc. Fortunately, the number of administrators doing such activity is usually not that large, so we have an opportunity, if we see activity we suspect might be malicious, that could also be interpreted as an administrative task, that we can go and deconflict that activity with those network administrators. Now, there is a possibility that this activity could be related to an insider threat, where an administrator is using their elevated privileges in order to conduct malicious activity. So we should be careful about going to individuals or administrators first, especially if we suspect we are dealing with an insider threat incident. Security software is also another common source of false positives. Security software needs to do some of the same kind of things that malware will often do as part of its execution, like read process memory space, monitor for file changes, kill processes, if that is one of its response actions, etc. In many ways, security software often looks like and behaves like rootkits. While we can usually assume normal users do lack the technical ability to perform some of the actions we'll be looking for a lot of times as part of our analytics, developers are an exception to this rule. Developers will often be performing activity that may resemble most activity, particularly if they are part of our threat emulation team or our network defense team. These staff often have the technical know-how to use some of the more advanced tools and command lines in our systems. They may often look for malicious activity. They often will also interact with remote systems as part of their daily tasks. Of course, there's always a possibility of misconfigured systems or software that are doing what we may consider weird things in the environment, or things they should not be doing for what we understand their configurations are supposed to be. We also need to be aware of ourselves, particularly as our investigation goes on. We might, in the process of our investigation, start interacting with systems and performing activity that may itself look like malicious activity, like remove these executing scripts or dumping memory from machines. You may think to yourself, what team would not recognize their own handiwork in the environment? But I've worked in events where one team member flags an event they see as being malicious, when in fact it was another team member doing the activity. This is why team communication is very important. And last but not least is humans. Humans are notoriously unpredictable, and in many networks, the end user is the biggest cause of problems in the network. Try as we might, we cannot predict everything our users will do. So keep that in mind, that if what we're seeing is unusual in the environment, it could be the result of an adventurous user trying to troubleshoot a problem or test out some new thing they saw on the internet. Let's look at the node graph example that we saw in the previous lesson. Node graphs like this can help us determine whether events are malicious by looking at the relationships to other events. In this example, if we had nodes on this graph that we'd already determined were malicious and the event in question can be tied directly to it, we might be more certain that it is in fact also malicious. Similarly, if we determine the events we're looking at is malicious, and we see a bunch of other events coming off of it, we can tentatively conclude that those events are likely malicious as well. Let's take a look at this step in the context of our scheduled task example that we've been using throughout this course. In this case, we are outputting events in a table format, and we have a couple of events of varying degrees of suspiciousness. Most of our events share a common task name, Chrome Update, and even the executables in question look very similar. However, one is a slightly different name and is being run out of the temp directory. This might indicate that an adversary is attempting to camouflage as a known similar executable. But alone, that might not be enough. But if you look at the trigger, the run level, and the author, we see further differences. And perhaps more importantly, we see that as not only is this Chrome update running when the machine is booted up, it is also running at the highest available privilege level available to it, whereas the other ones are running daily and the least available privilege. This might reinforce for us that this Chrome update exe out of the temp directory is in fact malicious. This conclusion might be further reinforced in seeing a very similar looking task, except it's running a different command, stage1.exe. This certainly looks more suspicious than the other Chrome update.exe. It may even give us an indication of what this malicious Chrome update.exe really is. Perhaps this name was a mistake on the part of the adversary. They forgot to rename their executable. Lastly, we have an antivirus scan task created. As you may recall in our previous slide, we discussed how security products will often conduct activity that may look like adversary activity. But because of that, adversaries may attempt to masquerade as those processes to conduct their own activity. If we look through the rest of the event at the trigger, the run level, and the author, and cross-reference that with how Microsoft's Defender antivirus tool usually runs, this matches those characteristics. Therefore, we might conclude that this is likely benign. Let's quickly review what we talked about in this lesson. You should now know what we mean when we say evaluating hits as part of our hunt flowchart. We explored how threat intelligence can help us evaluate those hits we are getting from our analytics. We reviewed some potential sources of false positives and saw some examples of how we can interpret results from our analytics.